Good morning, dear students. This is Sudesh Shukla. So, hope you are well. I wish. So, let's start our discussion for one of the subsystem of the space segment which we have discussed in our previous video. Attitude and orbit control. Actually, dear students, there are few major parts which are considered for AOC subsystem. So attitude and orbit control, we all know that AOC is used to control the orbit of the satellite, besides helping to maintain stabilization and its position. This control can be effected from the satellite itself and from ground. So this subsystem consists of mainly this AOC. Four major parts. First is sensors. Second is propulsion system. Third is attitude control. And the fourth one is orbit control. So these are the four major parts of the attitude and orbit control. So first of all, let's come to know what are the forces acting on a satellite. क्योंकि इन सिस्टम का रोल तभी हमें समझ लगेगा जब हमें ये पता हो कि वो अपने रिस्पेक्टिव ऑर्बिट से डाइवर्ट क्यों हो जाते हैं, क्या रीज़न है कि उनके ओरिएंटेशन में चेंजेस होने लगते हैं, जिसके लिए हमें इन सब सिस्टम्स की रिक्वायरमेंट पड़ती है. दैट वी आर इन नीड ऑफ दीज टाइप ऑफ सब सिस्टम्स. So there are number of forces working on a satellite which tends to change satellite attitude and orbit beyond a permissible limit. So the forces among are asymmetry of the Earth's gravitational field. The Earth's gravitational field. We all know Earth is not a true sphere. It is bulging at the equator. Bulging means ups and down. By about 65 km at the longitudes of 165 degree east and 50 degree west. This causes an acceleration, and hence for accurate positioning the satellite must be accelerated in the opposite direction, and that satellite can be accelerated in opposite direction by firing the rocket motors called thrusters at appropriate intervals. क्योंकि Earth is flattered at the poles by about 20 km, but this has a little effect on geostationary satellites. Means due to that flattened surface, there is a less effect on the satellite. The second one is gravitation that means gravitational force, gravitation due to sun, moon and other planets. They set up by rotational moments. If the satellite is not perfectly balanced, moon being the nearest heavy mass and has its maximum effect. Comparably to the sun, the moon is closer to earth. So the gravitational force by the moon has a larger effect on the satellite. The third one is pressure due to solar radiation. Pressure due to solar radiation. It can also change orientation. That means spin axis of the satellite. As we all know, the earth is rotating around the sun and that satellite rotates around the earth. So due to that solar radiation, that radiation exerts a pressure on the satellite and that effect is on the orientation along the spin axis of the satellite, that will disturb the orientation of the satellite and may cause a problem. So let's discuss about this sensor. So for attitude control, two types of sensor are used in the satellite. First is earth sensor and the second one is sun sensors. So sensor, not a sensors. So generally if we talk about this earth sensor, we say this is a infrared device, passive infrared device operating in 14 to 16 micrometer wavelength. It senses the infrared rays coming from around the horizontal plane. As we all know, there is a sharp temperature difference between the space and Earth's horizon. Sharp temperature difference. That is, space is cool and this Earth is warm. So two Earth sensors are used, positioned at 5 degree north and 5 degree south of the spin axis. So when the spin axis of the satellite is correctly maintained, the output of the north and south sensors are in phase. When these two sensors are balanced with each other, they are said to be in same phase. Otherwise, if there is variation within the degree of these two sensors, there will be phase difference or they are out of phase. The phase difference pulses are sent to the Earth station and they measure Earth aspect angle by the phase difference pulses which are being sent to the Earth station. The measurement of Earth aspect angle is done from there, from the Earth station or from the Earth segment subsystem. So second is, what about this? Sun sensor. This is a fan-shaped field of view. This operates in visible spectrum and uses a photocell for detecting solar radiations. There are two solar sensors, one parallel to the spin axis, another canted at 35 degree. Pulses from the sun sensors are sent to the Earth station to determine the solar aspect angle. So data from Earth and Sun sensors is analyzed and orientation of the satellite is accurately determined by the computers at the Earth station. Commands are generated and sent to the satellite to fire the rocket motor for correcting the axis. So this is all about the Earth sensor. Now the next is propulsion system. It is the reaction control system carried by the satellite in the geostationary orbit so as to generate forces on it whenever required. The reaction control system has a supply of fuel and it helps the satellite to move to its assigned position in orbit to maintain it in that position and to maintain the direction of spin axis attitude control in the case of forces that perturb it. Usually a propulsion system consists of 3 units. That means this consists of 3 units. The first one is low thrust actuators. The second one is high thrust actuators. And the third one is space shuttle launched vehicle. So low thrust actuators devoted to attitude, that means low thrust actuators, which is one of the unit of propulsion system that is devoted to attitude and orbit corrections, that provide an annual velocity increment of the order of 50 meter per second annually. The next is high thrust actuators, which provides the velocity increment required for the geostationary orbit injection at the transfer orbit apogee. And the third space shuttle launched vehicle. It provides the velocity increment required to inject the satellite into the transfer orbit. That means overall these three are devoted to attitude and orbit corrections while increasing the velocity. So out of these three propulsion units, the low thrust actuators are of much importance for geostationary orbit because it is responsible for keeping the satellite in its orbit with its perfect attitude till its life end. Dear students, the low thrust actuators can be either chemical one or the electrical one. Among these, this is having a more importance, and it may be either chemical one or electrical one. The chemical thrusters, the chemical thrusters have a thrust level of between 0.5 Newton and few 10,000 Newton. In chemical thrusters, gases are generated at high temperature by chemical reaction of propellants, which may be either solid or liquid. The gases are then accelerated by a nozzle, and then it results in providing the thrust. The electric thrusters produce a thrust only in between 2 and 10 millinewton. That means the force which are being required, that is not compulsory that it is always a high force, that it may be low. So electrical thrusters provides force in between 2 and 10 millinewton, and the chemical thrusters provides 0.5 Newton to few 10,000 Newton. So electric thrusters, they provide thrust by accelerating ionized mass in an electromagnetic or electrostatic field. In communication satellites, chemical thrusters are used. This is mostly preferable. So this is all for propulsion system. Next is attitude control system. Dear students, the attitude control of a spacecraft is necessary, so the antennas must be pointed correctly at the earth. The gravitational forces from the sun, moon and planets will set up rotational moments when the spacecraft is not perfectly balanced. These are carried out by control loops based on error detection and decision system. Generally, let me draw a figure for it. Here this is attitude, this is reference dynamics, adder, here sensor information, here it is control circuit, and here it is activator. This is basically the students a control scheme for the attitude control system. Activator, here it is adder, and here we are taking disturbance sensor output, disturbance sensor output. Here it is spacecraft, So basically these all things are carried out by control loops based on a error detection technique and decision system, which is shown in here in the figure. So they use the telemetry tracking and command, that means T, T and C. I have told you these are the points for the subsystem, space subsystem. We will discuss, I will post a video regarding this T, T and C. So they use the telemetry tracking and command subsystems for information exchange between satellite and Earth. The attitude control may be generally either it may be passive attitude control or it may be active. So in passive attitude control, the required attitude corresponds to a position of a satellite, while for active attitude control, the satellite is unstable or sufficiently stable within the desired attitude configurations. So mainly 4 operations are required for this. One is detection of the satellite attitude. Let me write. One is detection of the satellite attitude. Another is comparison with the reference axis. Comparison with the reference axis. The third one is determination of the corrective torque, that means determination of the corrective torque. And the fourth one is correction of the attitude. Correction of the altitude by actuators mounted on the satellite. So there are the 4 operations which are required for this, and we all know any spacecraft is governed by using 3 axes. Yaw, roll, pitch, we will go. We have discussed this in our video where I have explained about the attitude and orbit control subsystem, 3 axis method and spanning the satellite technique. So in order to control the attitude in space, the satellite has to be properly oriented using momentum wheels and thruster motors in these 3 axes. So the major methods were spin stabilization or 3 axis body stabilization. So dear students, the last we will discuss the need of attitude and orbit control, that is need of attitude and orbit control. The change in the spin axis of the satellite will cause pointing error between the satellite antenna and the earth station antenna. That means change in the spin axis. So this will reduce the signal at the receiving side and will degrade C/N ratio. Hence the need of maintenance of correct attitude, as the extra forces can change velocity of the satellite and therefore angle of inclination of the orbital plane with respect to the equatorial plane. The satellite will become non-geostationary. So this will require steering of the earth station antenna to get the best signal from the satellite. Thus, correct attitude and correct orbit are essential requirement for the optimized performance of the satellite link. So here, from this point, need of attitude orbit control, we come to know ki why we are in need of all these things to be done. कहीं ना कहीं पोजीशन में चेंजेस, कोऑर्डिनेट्स में चेंजेस, those all are by these external forces, external things which affect the orientation, the spin axis of the satellite. So we are in need of correction of these things so that satellite can effectively provides the service and we can use the services which are offered by the satellite. So I hope you got my points, and if you have any doubt you can ask to me. So thank you students, thank you so much for this discussion.